Hi, in this video I'm going to show what's new in Waveform Generator version 1.3. I will not go through everything that's changed, but if you want to, you can go to the help menu and the history, and you can see what's been added, what's been changed, and here in the lower part, box or items I have found and fixed in this version also. I will go through most of it, but otherwise you can look here for additional things. In this version, the database have changed, and that's because in this version I finally added the ability to make wavetables. In previous version, you can only make single cycle waveforms, but in this version, wavetables can also be created, and that means the database have been changed. So if you have a previous version of this program, the first time you start it, you will be warned that the database have changed. And we can see this. I have a database here that have not yet been updated. And when I try to open it, I will see this message box that's inform you that the database need to be updated. And it suggests that if you have not done so already, make a backup of the database. If you answer no here in Danish, it will not update or load the database, but otherwise you have to press yes. And the update is only taking a few fractions of a second. So already this database have been opened. So if I choose another database, of course I chose someone that did not exist. So let's try again. For example, this one. And I revert back to open this one called not updated. It have already been updated. So the second time you try to open it, will simply open it without anything. Also in this version, you can now import waveforms and wavetables from another database. So if you share waveforms or wavetables with a friend, and they send their copy of their database, you can then import it into your own database. The license have changed, is less restrictive. So basically you can use the software as you want to now. If you want to use the waveforms or wavetables in your music, or you want to use it in, if you make sound banks or patch banks and so on, you can use it there. If you are a brand new user to this software, you can find all the previous videos or links to the previous videos here. And at the least, I suggest you look this tree view video and perhaps the overview video. The overview video will tell you a little about everything. And this video will tell you specific how to use the tree view, and using the tree view for waveforms and wavetables is more or less identical. So it's a good idea to watch that video if you have not done so already. Let's first look at the minor things added or changed in this version. We begin in the settings form. You are now able to dial in a filter that used when you import audio into the program. When you load WAV files, for example, you can apply a filter for the data and it works like the filter you can see when you double click a waveforms. I've added these three items down here that you can change negative harmonic volumes into phase shift instead when resampling to an additive waveform. I will show later how it works. You can choose to auto reduce files that you resample into a hand-drawn waveforms, and you can dial in a minimum width of phase size in degrees, that when you perform this reduce function, that will try to identify and generate line segments. And this also I will show later in the video. In previous versions, there were 3 presets for audio export. There's now 6, and since this program can now handle wavetables, I added 6 presets for those. What you can use the presets to is to, for example, if you want to export with different number of samples, or you want to export to different folders or different settings here, you can generate presets for that. whenever you export, you can either choose one of these predefined presets, or you can manually set it up. But again, I'll suggest you make these presets. You don't have to make 6, but make the ones you use. Let's look at partial waveforms. In the partial waveform, a partial waveform is a waveform that consists of 2 advanced waveforms. For example, you can set up a sine and a triangle, and you can define a split point, for example, 50%. So at 50%, it will use the sine. At the last 50%, it will use the triangle. In this version, I shorten the name in these buttons in order to make room for this small illustration. So now you can see the small illustrations of each of these 2 waveforms that make up this partial. And if you double click, you can see and hear how this one sounds. So that should be more easy to identify how they're specified, how they're set up. Also, the compound waveforms, I made some changes. In the previous version, I think it was called variant. In this version, I renamed to algorithm and added flow in parentheses. And you have this cryptical value in this combo box. So in this version, I add an illustration that hopefully better show what this algorithm does. These one in blue named parts is the 4 particles. And these in orange called OP1 to OP3 are the 3 operations you have here. So hopefully this illustration clearly identified that operation 1 is affecting partial 1 and 2. Operator 3 is affecting partial 3 and 4. And finally, operator 2 here in the middle process the output from operator 1 and operator 3. Since operator 2 is the last one to be executed, it will be marked here in orange to identify this is the last. And this symbol here is simply the result of the chosen operation. They each have a symbol associated with them. So quickly, just looking at these 3, you should be able to see what's going on. Choosing the alternative algorithm, you can see still operator 1 is performing its work based on the content of partial 1 and 2. However, now operator 2 is working on the output of operator 1 together with the partial 3, and last operator 3 is working on the output from operator 2 and partial 4. And in this algorithm, the last one is operator 3, hence the third one here is marked with this symbol. Also in this version, I added a new compare operator. And it's simply used to pick which of these waveforms are used and when they're used. For example, let's do 2 sines. And this second sine we define with frequency modulator. So it have 3. And we choose a sample and hold value converter that we set to 4 bits. And now we have this new compare. Before I show this compare, let's show the splits. The split you can choose. Sorry, that was the replace. The splits. It will be 50% of the first waveform and 50% of the last waveform, and then you can define a transition area here. So basically, you are splitting the phase. In this case, the first part of the phase is the first, the last part of the phase is the last. Choosing the compare operator, you instead split by values. So you can choose the upper part of one waveform where that other waveform is above this line. For example, this one, left greater than 0, it means everywhere where the output of the left waveform is greater than 0, it will choose partial 1. otherwise it will choose partial 2. So in this case, we see the exact same result as before, because it's the first part that this is positive, hence it choose this part. Instead of dialing in 0, you can choose a value from this combo box. You have a lot of small values near the 0 line, and that's because it's the place where you most likely want to split. However, you are able to choose from 0.01 to 0.99, both positive values and negative values. So if I simply use the scroll wheel on this field, you see I can dial in when I want to choose from one waveform or the other waveform. Here it slows down because it's a lot of values near 0. So you can get this effect. You can see left greater than, left less than. For example, if we dial in the 0 value here. So as soon as the left is below the 0 line, hence below 0, it will choose that. Otherwise, it will choose this one. But you can also choose the values that are near 0. So everywhere you have values here near 0, it will choose the left. Otherwise, it will choose the right. And you can define that area. It's not, when you choose this one, it's not important if you choose positive or negative value, because it'll take the absolute of those values. But let's dial in a higher value, for example, 0.25. So here, whenever this is within 0.25 of the 0 line, it will choose the left partial, otherwise it'll choose the right partial. So here we have part of the sign, here we have part of the sign, and here we have part of the sign. These areas, for example, here and here, you see we are far away from the 0 line, and here we are far away from the 0 line, so we'll choose partial 2 instead. And you can also choose near edge. So instead you dial in when this waveform is near the edge, and the edge means +1 up here and minus down here. It will choose the left partial, otherwise it'll choose the right partial. So you can define how near it should be, or how far away it should be before it chooses this waveform. So that's the new operator added to compound waveform together with this new illustration. Also in this version, I've made some changes to the basic operator waveform. For example, if you do an advanced and choose an operator and choose edit. Here also you now have a small illustration. This algorithm can be hard to read as text. This 1 less than 2 indicate that operator 2 is manipulating or modulating the phase of operator 1. And hopefully this illustration makes it more easy to read. So as you choose other algorithms, you will see different illustrations over here. Also in this version, I added some extra algorithms. As memory serves me well, in this version, I think there is 17 algorithms where there was 11 in previous version. Also in this version, you now see a small illustration of each of these operators. For example, this one have a frequency of 2, hence you see 2 signs. So if I change it to a triangle and change it to 4, you will see 4 triangles in this small illustration here. And you can double click each of these to see a larger version or to hear them. Also in this version, I did some change to the basic additive waveform. Choose to randomize it and then draw something in. In the previous version, if I wanted to delete all these and keep this part, I would have to click, and while I have my mouse pressed. I had to move slowly. If I move quickly, it will skip some of them. In this version, I can simply right click here and choose clear remaining, and it will clear these volumes for these remaining harmonies. And what it means is remaining is all that's right of the one you click. So now they are all cleared. So it's easy to remove them. For example, if I do a random waveform and I turn it into a basic, and I put my mouse here at the, for example, 33rd, I can right click and see clear remaining. Now all of these are 0, and we only have values over here. So that's a way you can reduce the number of harmonics in use. Another thing to notice is this one. As I resampled a waveform into an additive waveform, you will see some of them are red and some of them are blue. If you look here in this section, you can see this first one is it's red. It means it's a negative value, and we can see it's a minus 100%. This third one is blue, hence it's a positive value, so it's a positive 27%. And here again, we have some negative values. If you want to change these into positive values, you will have to, you can right click this one and it worked the sign. It changed to a positive value, but the waveform changes here. So in order to return to what we had before, I need to shift the phase by 180 degrees. Here we have the fifth, again, inverted. And it's also for this one, 180 degrees. All of the odd are 180 degrees when you convert them, but all of the evens are not. It's different values. So instead of having to do this manual, let's undo a few times and let's reintroduce all of the remaining we had here values. What we can do in this version is we can right click and choose this one, convert negative to phase changes. It means all of these red one, all of the negative will turn blue. Hence, they will be turned into positive values. However, in order to not change the waveform, it means it have to dial in different phase settings, and it will do so automatic. So now only positive, but we have some phase changes. If you prefer that every time you resample a waveform into an additive waveform that it will do this work, you can now use that settings value I shown before. This one, when enabled. Let's do a random waveform again. Turn it into a basic additive. You see now it's only positive values. However, we now have phase shifts. If instead we turn it into an advanced waveform, advanced waveforms don't have positive and negative values, but instead it have operations. And now it's all add operations. Had we not changed that thing in settings, some of them would be add, some of them would be subtract operations. So you can set that up here in settings if you prefer it like that when you resample into an additive. In this version, I also fixed a problem with, we can try open this database. And if memory serves me well, it was number 39. No, it was 12. If I open this one, turns it into a basic additive, edit it, and then edit as CSV. You see this 34th harmonic. It's a very, very small number. So it's being listed as exponential notation. And in previous version, the program did not like that. It only tried to pass this text if you make a change. So if I click OK, it does nothing. However, if I Instead of 62, we say 61 here. We will not see any error message. It will simply understand this exponential notation, and you see it's have actually changed it here to 61. However, in previous version, it would result in an error if there was exponential notation. You can now handle it. Also, this the phase value for each of these, in previous version, it had to be an integer number. However, now in this version, it accepts 3 decimals. So here we added that, and when we add it again, we see it actually retained the decimals. So it's now more precise in phase changes. These precise phase changes can only be entered here in the CSV. When you edit as CSV, you cannot dial it in with the mouse. With the mouse, you cannot dial in anything more specific than in 5 degrees intervals. And it also goes for advanced. If I convert it into an advanced, and I edit in previous version, you had a drop down up here. But now it's changed to a numeric drop down, so we can again insert precise phase shift values. So these were the changes to the additive waveforms. Many changes have been done to the hand-drawn waveforms. Let's do a random one. First of all, I added some new draw tools. And also in this version, I added the ability to disable snapping. Here we have a preset set to 15 degrees and 1/6. So you see, I have this blue cursor lagging behind. It's my snap cursor. And it's actually this, when I do perform a draw, it's actually the snap cursor that's used. Here you can see the location of the blue snap cursor and the physical black cursor, but when I start a draw operation, you can see it start at the position of the snap cursor. Also in this version, you can enable lines. It's more easy to showcase this feature. This alignment more or less simply draw the snap cursor as one big cursor filling the entire draw area. And the reason to draw this, for example, if I wanted to stop here but draw an S-curve exactly below this one to this point, without these lines, for example, like this, it's hard to determine where this point is exactly. Also, you can see I cannot hit that point exactly because snapping is enabled. In previous version, you had to choose, for example, max resolution, then find this exact point, then you can revert to this chosen preset. In this version, if I press and hold the Alt key, you can see now the blue cursor is aligned vertical. The face is exactly where the black cursor is. However, as I move up and down, it will still snap to 1/6 of a grid field that's 45 degrees. If I instead press and hold Control, I can now precisely move the snap cursor up and down to the exact value I want. However, it's still snapping in the x-axis, and if I press both Control and Alt at the same time, I can, even though I preserve this preset, I can place my cursor wherever I want, and as soon as I let go of them, it returns to the normal snapping. So if I enable the align and choose an S-curve and press and hold Alt, you can see I can precisely find a point down here that's exactly where these points are. I can then start my draw operation. I don't have to press Alt anymore. I can release it. So now this line down here starts exactly where this point was. So that's thanks to this alignment and pressing and hold Control and Alt. In this version, I write down here that you can, for example, it's not new, but when you while the left button is pressed, you press the right button to cancel draw operation. And it says Alt disable phase snapping and Control disable value snapping. Regarding these new draw tools, if I wanted this point to be below, lower than this point, it's not possible because you cannot draw below the draw area. However, what I can do in this version is, for example, I can, let's dial in 0.7 and normalize. It means this value is now at, you can see down here when I move the cursor, it's at 0.7. So I have, by using this normalize all, I have given myself a little headroom. So now I can draw in S-curve from this point down here up to here. If I did not draw all the way, for example, if I drew from here to here, I can now normalize everything by dialing in 1.0 and normalize all, and it will again fill out the entire area. Instead of using this normalize all, you can also use the draw cursor to normalize a section. For example, if I press and hold Alt, and I want to normalize this section to 1.1, I have to choose this as a draw operation. And you see it now chooses this to be the section I normalized. Or I can dial in a lower value to have it near the 0 line. That was a low value. So it pushes the line down. So either normalize all or draw in the section you want to draw. Let's save this waveform and add a shift, DC shift offsets, and then resample the waveform. Let's shift the other direction, like that. If you have done some operation where these ends are not at 0, you can now draw in a shift. You can try to guess how much to push it down. So to push it down, it's a negative value. And then you can draw in, I should not let go of the mouse. You can draw in a shift. Here it's too low below, so you could cancel the operation and change this value. However, as long as I keep my left mouse pressed, I can also change that value by using the scroll wheel of the mouse. So I can try to see if I can hit this point and let go of the mouse. However, instead of trial and error, I can right click here and set choose an average start and end, and it will find the average value that the start have to be pushed up and down, or the end have to be pushed up and down. So choosing this menu item, you can see it's simply just dial in that value that's it thinks it should be, and you can press Shift All. So it will try to move the waveform up and down so it fits. This is, of course, only possible when the end and beginning are at the same location as they are here. For example, had this last part been looking like this instead, then when I ask it to find, then this will be a little above, this will be a little below, because they were not perfectly aligned. I can choose to say, okay, I want to align the beginning. I don't care about the end. I want to find the amount of shift to fit the start. Shift all. Now this point is at 0. And I can simply choose to redraw this part where it will be at 0 then. So that's the new shift. The sign is, you can draw in the sign, for example, in words. When I start drawing, the section I draw is drawing will be inverted. For example, if I draw everything, the entire waveform will be inverted. I can also say I want it to flip. When I flip this point, the distance from here to here will be changed to the, it will use that distance, but change it from the top. So this point will go approximately here. This point, it will be a little below because it's above 50%. Sorry, that's when I do a positive flip, it will do, as I said. So, for example, pressing Control and drawing here, you'll see it will flip the top part. I can also see I want to flip the negative part. It's below 0 here. It will only flip this part. Or I can flip the entire waveform. So that's the new draw. Beside also you can choose positive and negative. This part is negative. I can say I want to force this part to be positive. As I continue drawing, nothing will change up here because it's already positive. Now we come to negative values that will also be turned into positive values. So now we only have positive. And all of these three, you can either draw in their effect or pressing one of these all buttons to do everything. Another feature in this version regarding the draw tool is this reduce. Let's choose, this waveform. Right now, it's a basic waveform with some phase converters and value converters. But when I resample it into a hand-drawn, it will actually take more than 4,000 samples from that original waveform in order to turn it into a hand-drawn waveform. And now in this version, you can reduce those numbers of samples because from here to here, it's all the same value. So you don't need all those samples. You can have a point here and a point here, and then in between the rest can be found by interpolation because it's simply linear. Here we have ever-changing slopes, so these parts cannot be reduced. Perhaps there is a little area here with values, samples that have the same value, so we can reduce a little of the samples here. But again, here almost 25% of the waveform can be reduced. As part of this reduction, it will try to identify line segments. If we reduce this point to this point, instead of it being a sampled part of the waveform, even with less samples, we can tell the program to turn it into line segments. If it had been drawn as a line, for example, we can do a line here. Now this is a line segment, but the program can do that also automatic. And when you do that, it will try to do that, but only if it can find a section where the phase is wider than this value in degrees. In this case, it defaults to 3. So if it can identify a section that's at least 3 degrees wide, it will try, and samples are linear aligned, it will try to reduce it into a line segment. And we see that when we hit the reduce button, first of all, we are told that how much it has been reduced. And when we press OK, we can see this have been identified as line segments. These line segments are about 90 degrees. So if I undo and I dial in a value larger than 90 degrees, when I perform, it will still reduce to 50%, but it will not turn these into line segments, hence we'll not see these red dots. So if I dial back to 3 again and reduce again, it will turn these into line segments. This value is the one you saw in settings. So if you never want the reduction to turn parts of it into line segments, simply set it to 360 degrees. Personally, I like this value near 3 degrees because it's more easy to edit as a line segment, I think, and also If it starts to get less, that you get very small line segments, so it can perhaps be a bit annoying with all those three red dots in your hand-drawn sections. So that's the changes to the hand-drawn waveforms. We added also a new lag smooth value converter. It can be seen a bit as a smooth operation. Let's choose this one and simply turn it into a hand drawn so we don't have any phase and value converters in use. If you do the smooth operation, you choose the area width in phase it should try to smooth, and it does that by taking multiple samples. So you choose the size of the area and the number of the samples. And the higher you dial in this, the more it will smooth. But as you can see, the beginning and the end start to move. Here it's almost, so this waveform is not beginning and ending at the 0 line. However, as I'm smoothing them, they will change the vertical position. In this case, they'll actually near the 0 line, but that's not always the case. Let's turn it back and then try to see if we can actually perform a shift here. Here we have a waveform beginning and ending at the 0 line. And let's perform this move again and see if you see here, they actually move away from the 0 line as a result of the smoothing. This new lag smooth is kind of a smooth operation, and it works in a different way. The reason it's called lag is because as a result of this operation, the changed waveform can start to lag behind the original waveform. As you can see, this top part, as I lower this value, it starts to move a little left back to its original value. So now when I start to increase this, you will see this left part start to move more and more to the right as a result of the smoothing. However, what this lag smooth will do, it will never change the vertical position of the end and the start, no matter how high value I dial in. These values that were before at the 0 line will stay at the 0 line. And it's using, internally, it's using a running average. So the higher you dial in this value, the more values it have to extract for each point to draw this. It have to extract 110 samples and then calculate the value of the average and then use that before it takes the next point and have to extract 110 samples. So both the smooth and the lag smooth are costly effects to use. They cost a lot of CPU power. So what you can do is when you have when you have smoothed the operation, you can simply convert it into a hand-drawn, then now it's simply a hand-drawn waveform. And this one, I expect perhaps we can reduce it a little here in the beginning, but basically it's ever-changing value, so I don't expect the reduce to get a lot of... So you see, we had a section here that's obviously it's wider than 3 degrees because it's been turned into a line segment. So that's most likely the only part it could reduce. The rest is still a lot of samples. I did some changes to the exponential value converter. In the previous version, you could only choose this setting here, but it have added an extra variant in this version. So you can tell it to perform this in the full range or only the positive value. It means it will only do it up here, but not here. So as I changed, you see all those above the 0 line will change, but those below will not. or we can choose to do it only in the negative. So if you need to have different things, you can set one to work on the positive and another to work on the negative. So for example, we can dial in a very low value in the negative and a very high value here in the positive. So that's the change to the expression value converter. Another thing changed in this version is when you export to a waveform, to an audio file. If I export more than one waveform into each file, we can now dial in a sample drift. For example, if I want to export 100 waveforms, we now have this sample drift. For example, if I choose 600 samples per waveform, it means that when I export 100 samples of 600 samples, 100 waveforms of 600 samples, this file will contain 60,000 waveforms, samples. And all of them all of those 100 waveforms will have exactly 600 samples. In this version, we can dial in a sample drift. For example, if I set it to 10%, you can see up here that with this amount of samples per waveform, it will result to a plus and minus 60 samples. It means if I were to export this now, I would generate a file that still have exactly 60,000 samples inside. However, they will not all be 600 samples per waveform. It will be a random size per waveform, and the maximum size would be 660 because it would be these 60 plus the 10% equate to 60. Or the smallest would be 540 samples that you get when you subtract these 60 from the 600. So, for example, used with this analog factor, it's a way to generate some kind of imperfection to your sample. So when you play it back, it would not be 100 identical sounding waveforms. There'll be a little change because some would be a little shorter, some would be a little longer. And if you use it with the analog factor, the phase of each waveform will be affected and the values of each waveform will be affected. So perhaps it would be a little less digital sounding if you use this sample drift. And this sample drift is, of course, part of the presets you set here. In this version, a lot of it changed regarding the expression waveforms. In previous versions, we only had this expression field, but now we have 3 macros and 3 slot conditions. The slot conditions can be seen as advanced macros that can be repeated, or there can be a condition whether it should be active or not. And then we have this new slot index, and we have a feature to show the result of all the macros and all the slot conditions as the full expression, as the full expression is no longer just in this field. In the help menu, or the help info here, I've changed a few things and added a few things. For example, this fraction is a new command. In previous version, I found out the apps command was not working as it should, so I fixed it in this version. There are 2 new variables, D and U, for the phase. And there is all this with the macros and the slot conditions, how they're used. So that's updated here in the help. Also, many of these examples can now be found in a version that utilize macros and or slot conditions, so you can see how they're used. So let's look at the new variables. For example, if you hit the sign, you see sign of X, and x is expressed in radians. It goes from 0 here, and it ends here at 2 pi, which is equivalent to 6.28. And for example, now we have the u variable that holds the phase as a unified value. So instead from 0 to 2 pi, it goes from 0 to 1. So if I simply replace the x with a u, we now only see approximately a sixth of a sign. So we'll have to multiply by 2 times pi, and now we see it as a full expression. And the reason I included this u variable was simply because if you get an expression from somebody else or from some other software that uses the phase as a unified value from 0 to 1, it's more easy to reuse that expression in this software. But whether or not you use x and or u is up to you. For example, if I simply does an expression using x, it will simply go from 0 to 2 pi, but as the waveform is automatically normalized, you cannot see it. So for example, if we subtract pi, now it will go from minus pi to 0 to pi. And if we use the u variable, it will now go from 0 to 1. So if I extract 0.5, we will now have an expression from minus 0.5 to plus 0.5. And the same can be used with the d variable because it works in degrees. So now it goes from 0 to 360 degrees, and if we subtract 180, it will go from minus 180 up to plus 180. I think some of you might want to use the u variable, but the d variable, I simply added it. I don't think many will use it, but if you want to, it's here. And the new frac function, it removes the integer part of a number. For example, if we do a frac of x, we will get this x as explained. It counts from 0 to 2 pi, which is equivalent to 6.28. And when we remove the fraction, it will go from 0 to almost 1. Then the fraction will be moved, and again it will go from 0 to 1. And if you count the tops, you can see 1, 2, 3, 4, 5, 6, and then 0.28. So if you have any need for this fraction, it's added in this version. If you want to do something else, for example, you can do a fraction of the u variable multiplied by 4. Now we see that the unified variable goes from 0 to 1. However, multiplied by 4, it will go to 0 by 4. And again, when you use the frac function, will almost count to 1, and then almost 2, almost 3, almost 4. And if you want to do something, for example, more useful as a wavetable, you could, waveform, you could multiply it by p. As some of you might remember, p simply has the value of plus 1 for the first half and minus 1 for the last half. So that's how the new variable can be used. As I said in the beginning of this section, the apps function was not working in a previous version. For example, if you do an apps of sine of x, apps take the absolute value, or said in another way, it will turn negative numbers into positive numbers. So the sign is always positive here in the beginning, but the last part that's normally negative is now, thanks to the apps function, turned into a positive value. So let's look at the macros. When you hover the mouse over these buttons, the tooltip will tell you the second line. Hold shift to see it with macros. If I click it unshifted, we see the normal shift of x. However, if I press and hold shift and then click the button, I will now see the exact same result, however this time implemented using the macros. We see this expression is referencing macro 1, and this asterisk tells us that the expression of macro 1 contains text, and this asterisk of macro 2 tells us that macro 2 contains text. It's not the same as they are in use, it's just to say they contain text. So if I enter some text here in macro 3, it's not in use, but the asterisk tells us that there are some text here. We can see the expression reference macro 1, and macro 1 is set up to take the sign of macro 2, and macro 2 simply contains an X. The expression can reference macros, and it can reference slot conditions. Macros can reference other macros as here, macro 1 reference macro 2. However, circular reference is not allowed. So for example here, if we said plus %m1, it will be an error because macro 1 is using 2, hence 2 cannot use 1. Slot conditions can reference macros also. However, macros cannot reference slot conditions, and slot conditions cannot reference other slot conditions. So I suggest you look at some of the examples I have made. As I said, the tooltip will tell if there is a function where you can hold shift to see it implemented. So let's look at the saw. As you might know, the saw is simply all the harmonics added. So here we have the first harmonic, the second harmonic with half its amplitude, the third harmonic with a third of its amplitude, the fourth harmonic with the fourth of its amplitude, and so on. So if I wanted to see it with the eighth and the ninth harmonic, I would have to enter here and change this to 8 and append again and change this to 9. And when you've done that a few times, it starts to get tedious. So what we can do in this version is hold shift and press this example. Here with shift, here without. It's a different expression, but the result is the same. And if you press this button, show full expression, you see this is actually the code that the computer is evaluating. And right now, perhaps it can be a bit difficult to read that this 2 plus 1 is actually 3 and 3 plus 1 is actually 4. So what we can do is we can press this button, check this button, check box, reduce expression, and it will reduce the this expression to make it more readable. But as we can see, it's the first, the second, the third, the fourth, the fifth, the sixth, the seventh. And the way we accomplish this is we simply have sign of X, and then we reference slot condition 1. And also we can see only slot condition 1 has an asterisk, so the macro 1 also have, and then slot condition 1. Slot condition contains this text that's referencing the macro, and then we have a usage. If we set it to insert replace, it will work exactly like a macro, that the content of the slot condition will be inserted only at one time. However, when it's set like here as append repeated loop, it means it will be appended multiple times, and the number of times it's included or repeated is defined here by slot index. So for example, if I dial it down to 1, this part is only added a single time, as we can see here. Sorry, I set it to 2. If we set it to 1, then we see it's only appended one time, and setting it to 2, it's appended 2 times, and so on. And we can set up an index variable, and this index variable is used by the condition. Either the index can be the slot index or it can be the loop index. The slot index is the value you define here, and it's a fixed value that, for example, now it's set to 3, and it's 3 all the time, it never changes. However, the loop index is changing. This part is repeated as many times as is defined by the slot index, and hence it's repeated 3 times, and in all these 3 loops, slot index have the value of 3. The loop index, on the other hand, goes from 1 to slot index. So here set to 3. The first time we append this, loop index will have the value 1. The second time it will have the value 2. And the third time it will have the value 3. In this case, it doesn't change anything if it's slot index or loop index, because we set the condition to all slots. So it will be included as many times as we have slots, in this case 3 slots. However, you can define that it should be only included every second slot on the odd slots, for example the first, the third and the fifth slot, or every second slot on the even ones, so the second, the fourth, the sixth and so on. Or you can say the selected index variable, either slot index or loop index, have to have an exact value, have to be greater than a specified value, or less than, or in between 2 values, both exclusive. Or you have this mod reminder division, this saying it have to be included every second slot. You could also do this with this one, where you say index divided by 2 equals either 0 or 1, and this can be defined with these 2 A and B variables as listed here. For example, if I choose this one, the A becomes active. If I choose this one, both with A and B, both A and B are active. And choosing, for example, this one, A and B are not used. So that's the way slot condition works. It's simply, as I said in the beginning, it's a conditional macros that can be repeated if you want to. So in this case, where it's set to repeated, the higher I set the slot index, the greater the expression will be, because it keeps adding this part to the expression. And if I go back to 1, you can see that this value x times 2 is simply because this part of the slot condition reference macro 1 and macro 1 have been set up to use the loop index. So here setting it to 3, as explained, slot index is 3 all the time. However, the macro is repeated 3 times, and the first time it's repeating or using the slot condition, li have the value of 1, next time 2, next time 3, and that's what we see here. Let's revert to this one here. Yeah. For example, the last time loop index have the value of 3. However, when we add 1, it will be 4. So this last value here and here will be 1 times bigger than this one, or 1 bigger than this one. So that's a normal or perhaps easy to understand slot condition. However, we can do it a little more advanced. This square plus minus, pressing it without shift, it's all of the odd harmonics. We have the first, the third, the fifth, the seventh, the ninth, the 11th, and the 13th. This one is a positive, but the rest we alter between a minus, a plus, a minus, a plus, a minus, and a plus. And for that we would need 2 slot conditions. So if we press and hold shift and click this example button, we have the first part, or the first harmonic, and then we insert slot condition 1, and after that slot condition 2. And if we look at slot condition 1, it almost looks as it did before. we have a minus instead of a plus. And in this case, it's important that we set the index to the loop index, because we have define a condition instead of just choosing all slots. We say on all the odd slots, include this slot condition. And on slot condition 2, we instead set on all the even slots. So that means if we only include set the slot index to 1, only slot condition 1 will be inserted, and we can see that here only the one with the minus is inserted, so it's only slot condition 1. If I set it to 2, it will first insert slot condition 1, then slot condition 2, and if we dial in a value of 4, it would no longer alter between them. It will first have all of the slot condition 1. So here we have with the third harmonic and the seventh harmonic, and then we have slot condition 2 times, first with the fifth and then with the ninth, and that's simply because here this means that every time slot condition is inserted or repeated, it will happen before inserting this one. And both slot condition 1 and slot condition 2 is reference macro 1 that have this this small expression. The example with the saw, we had to use all of the harmonics, but with this square plus minus, we only need the odd harmonics, and we do that by multiplying by 2 and adding 1. So in this case, the first time it's repeated, loop index have the value of 1. So 1 times 2 plus 1 is 3. Next time it will be 2 times 2 plus 1, so it will be 5. So this is a way you can make a bit more advanced macros without, expressions without having to enter a long text. For example, if I wanted to add more manually, I would have to copy and paste and then change this to 15, change this one to 17, and so on. So instead, it's more easy, simply change this one and dial in a higher value here in the slot index, which will result in a longer expression. So that's the way these new macros and slot conditions works in combination with the slot index. This reducing expression, see it as an experimental feature. I have seen in some cases it doesn't do it correctly. I used it primarily while writing this feature debugging software as I think, for example, this is a lot easier to read than this long expression. It hurt my eyes trying to make sense of it, whereas this one is much easier. So sometimes I use it and I click it and see, do I see any change down here in the waveform? If you don't need to see this full expression, don't click it. Perhaps it will take a little longer to generate the waveform with a long expression than with a short expression. And these waveforms based on expressions are by far the slowest waveform to generate by the software. First of all, evaluating this text and inserting the value of all the variables for each and second loop just to extract a single value from the function takes time. But another thing is that these expression waveforms are not threaded. Normally, extracting values from the waveform can happen in a threaded way. For example, I don't know how many pixels I have from here to here, but let's say I have 1,000 pixels. It means to generate this illustration, I have to extract 1,000 values, and normally that can be done threaded, meaning you can have many cores on your CPU extracting those calculated values, whereas this is not possible for the expression waveforms because they are not running threaded. I could not get them reliable running threaded, so to produce this I simply disable the threading of generating these illustrations for this waveform. And the same when you export it also, the values extracted are not threaded. So what you could do if you for some reason thinks it's not necessary to save the expression, you could choose to resample this into a hand-drawn waveform when you're finished generating it. So these were the changes made to the expression waveform. Finally, it's time to address the elephant in the room, the new wavetables. In previous version, we only had this waveform tree view, but in this version, we have this new wavetable tree view. And it works more or less like the waveform tree view. If you are new to the software, as I said in the introduction, it's a good idea to watch this video on how to use the tree view. It's how to use the waveform tree view, but the wavetable tree view is more or less the same in its way of function. To create a wavetable, you simply right-click and choose this menu item. As you work more with the software, you will learn these shortcuts. As listed up here, a wavetable must have two waveforms, and it cannot begin or end with an intermediate waveform. It can have up to 256 waveforms within the wavetable. And if you have intermediate waveforms as here, they must be sandwiched between non-intermediate waveforms. And as of now, that it's not the case. This text is listed in red. And also this asterisk down here is in red, indicate that this is a non-valid wavetable. You are able to save these non-valid wavetables in the database. And one uses for that is if you have some wavetables you use as templates, you can choose to deliberately make them invalid by adding an intermediate waveform in the end, as it will ensure that it will never be exported, as the program will never export invalid wavetables. So let's add some non-intermediate waveforms to this one. And again, you can see here we have listed all the shortcuts that you'll learn as you use the software. So let's choose a sine. And again, and then choose a triangle. Right now it's still invalid because it both begins and ends with intermediate. So we can move this to the top. If you right click, we have this menu item, move to top, or move up or move down. And here you see it's home, up, down, and end using the shift keys. Without shift, arrow up and down simply moves from the slots within the wavetable. However, if I press shift and move up, I will move this non-intermediate waveform to the one slot up, and here again shift and arrow down. So now our wavetable is valid. This text is no longer red, and we don't see the red asterisk here. So now we have a wavetable with 4 slots, and up here you can see the first number is the selected slot, and the last number is the number of slots. These two non-intermediate waveforms are waveforms we specified. We chose the sine and we chose the triangle. However, these intermediate are automatic generated. So with these two intermediate, we see a slowly transition from the sine into the triangle. The non-intermediate waveforms are listed here with, illustrated here with a blue waveform. And the intermediate are illustrated with this light brown, dark orange color. Here in this field, you see the actual selected slot, and down here you see the entire wavetable. By default, it only shows the non-intermediate waveforms. However, you can click this box to see the intermediate also. So now you can see we go from the sine, and it will more and more fade into the triangle of this wavetable. And if you want to, you can double click and you can see the waveform used for this slot, and you can play it to hear how it sounds. And also you can double click the entire wavetables. There's no playback features here, but you can see a larger version of the wavetable. And again, you can toggle whether or not intermediate waveform should be part of this illustration. In order to add waveforms to the wavetable, here these first options, we can add these three non-intermediate waveforms, either an advanced, partial, or compound. And again, using Control A, Control P, and Control C, you can simply hit the keyboard. And also we can clone a specific waveform, or we can insert an intermediate waveform. For example, inserting intermediate waveforms is done with Control Insert. So right now we have 8 slots, so pressing Control Insert a few times, now we have 8 slots, and you can actually convert, for example, I can convert this into a hand-drawn waveform, and now it's simply a waveform like everything else. So now we will fade from this sign into this one, and from that one down to this one. All slots of a wavetable is normally normalized on export when you save the wavetable. And for the non-intermediate waveform, you can specify this normalization. It defaults to 1. So you see the first is 1, the last is 1. It means all of these intermediate are 1 also, because it will fade from one into the other. For example, if I lower the volume of this one, you see this is still 1. But these intermediate, they will slowly transition to a lower normalization as specified here by this last one. And there will be cases where you will have to do that. For example, if we go from a sine into an inverted triangle, like this, you would imagine that as we start to move, this peak up here would slowly move down while it being more and more sharp. Likewise, this will move more and more up until we end in the sharp, so we end in this waveform. And if we step through these slots, it's perhaps not what you expected to see. Especially this one, it looks strange, and the transition into this one looks strange. And perhaps you think there's a bug in the software, but actually the software is doing exactly what it's asked to do. Here we choose the next one. This one, if this peak should be moving down, we had expected it to be down here perhaps, but it's up here, and likewise it's down here instead of being here. And the reason for that is that these slots are automatically normalized. And this middle one that looks very strange, it's also being normalized. So the fact is that the volume of this one should actually be quite low. You are not able to specify normalization for these intermediate waveform. So in order to lower the normalization of this one, you'll have to convert it into resample it into a hand-drawn waveform. And now it's simply a hand-drawn waveform that you can change and do whatever you want to. But what you also can do is lower its normalization value. So if we put it here, now when we move through the slots, we see exactly what we had expected to see. Whether or not you want to lower the normalization of any of these slots will depend on what requirement you have for this wavetable. In most cases, I would not do it, because if you load this wavetable into a synthesizer, it means the volume will go down as you start to choose these middle slots of the wavetable. So I would probably find some other means to do this transition. This one we can convert back to being an intermediate, and then the normalization will go back to 1. Let's change this last one into a saw. And we remove this phase converter. So now we have this sine going into a saw. And right now the transition type is set to amplitude. And it simply means the amplitude for each and every point of the wavetable will fade between the position they have. For example, here the sine, we see it begins at 0, ends at 0. Whereas the saw, it begins at +1 and ends at -1. So these points will gradually move up, and this point will gradually move down. But again, this, if you look here, it goes up to this point, but already here it's in the top, so nothing will happen. It'll simply stay up there, where you might have expected it to go slowly up through all of the transitions. And the reason it's in the top here is simply because, again, each and every slot is normalized. Right now, the transition type is amplitude. We can also choose harmonics. When we choose harmonics, it will turn, it will basically resample our non-intermediate waveforms into basic additive waveforms. And we can choose with how many harmonics it does that. For the sine, it has no effect because the sine is actually just a single harmonic. But the saw is consisting of many harmonics, and we can choose a lower value, for example, 32. And now these harmonics will gradually fade in. It's worth noting that if you have a non-symmetric waveform, it can look strange when you turn it into harmonics. For example, if we choose to hand draw this one, and then draw an waveform that is not symmetric. You will see here, as soon as I change this into a harmonic, it's no longer looking like the original, and that's simply because this waveform is not symmetric. This last half down here is not exactly like this one. So the waveform will change when we choose harmonics as a fade. When you choose this fade, you can choose that the non-harmonics should not be changed into harmonics. So if we do that, this one will look exactly as it did before. However, these are being turned into harmonics, so therefore we see this big change between these two. So if that is an issue, simply use this amplitude fade instead. Also, we can choose how the fade should occur. Now we switch back to the amplitude, so let's go back to a saw. Sorry, it was a sine. So we go from sine to a saw. And the way we do it is, right now it's linear. So the change between each subset slot is more or less the same amount. However, we can choose a different way. For example, we can choose an S-curve. With an S-curve, there'll not be much change between these two first one, and there'll not be much change here between the two last one. But here in the middle, there'll be a greater change between them. And we can also choose a more sharp S-curve. It means there'll be even less change here between the first two and the last two, but there'll be more change here in the middle. Or we can choose a sinusoid, where we have little change in the beginning, the first two, but we have a larger change here with the last two. Or we can use a reverse sine. Then we'll have bigger change between the first two and little change between the last two. And then finally we have ellipsoid and reversed ellipsoid, which is just a sharper effect than the sinusoid. It means we'll have very little change between the first two, but a very big change between the last two. And when we choose the reversed, we'll have a very big change here in the beginning and a very large one here in the end. If we, for example, add some other waveform here, we can choose square. You might want to have one specific sound type of transition up here and another down here, and you can only choose one. So what you could do, for example, if you want an ellipsoid here in the beginning, you can right-click one of these and then choose to resample intermediate section to hand-drawn. And since I right-clicked this one, it means all of these will be resampled in one go. Now these are no longer intermediate, they're simply hand-drawn waveforms. So they will not use this transition type at all, so we can change it to a reversed. And now it's only affecting these. So we have basically ellipsoid transition here in the top, and then a reversed ellipsoid here at the bottom. Let's create a new. Simply right-click here and choose this one. And this time I'll use the keyboard. Control A, sinusoid, Control 8, triangle, Control A, square, and Control A saw. Press home to choose this one, then shift arrow down. Go down here, shift arrow up a few times. Control insert to add an intermediate, arrow down, control insert 3 times. So now we have a wavetable with 9 slots. And between the first 2 non-intermediate, we have a single intermediate because there's a not big difference between a sine and a triangle. So we don't need a lot of intermediate to transist from one to another. Here we have 2 intermediate to transist from the triangle to the square. And then we have 3 intermediate to transist from the square into the saw down. What you can do is you can right-click and then adjust the slot count. Right now, we have 10 slots. And the value it suggests here is simply the number of non-intermediate. So if I were to press OK, it will simply remove all the intermediate waveform. But let's increase the size of this wavetable to 16 slots. And we now have 16 slots in the wavetable. And these new inserted intermediate are not simply random inserted. As you can see here, we had 1 intermediate before. We now have 2, hence 1 was added. Here we had 2, but now we have 4, so 2 was added. And here we had 3, and now we have 6, so 3 was added. So it simply looks how many there are before you perform this slot adjustment. And then it will either remove or add in relation to how many there are. For example, if I now adjust the slot count to 4, as you saw, it removed all the intermediate, and if we adjust again and then increase to 16, now that there was no intermediate before we execute this, it have in this case added exactly 4 intermediate between each of our non-intermediate waveforms within the wavetable. And in most cases, I will suggest you don't add too many intermediate. There's no need to it, because even if I adjust the slot count to 4, as part of the export process, this can be exported to whatever I need, 8, 10, 15, 12, whatever wave slots. It can simply be asked to add the appropriate amount of intermediate waveform to adjust this wavetable with a specific size. Also, we can, instead of adding these manual, you can import, load a waveform from your waveform tree view over here. You can load specific waveforms, or if you have wave files on disk, there's no need to first import them into your waveform tree view. You can import directly into this folder. So if we move this down and this up, we now have this where this one was loaded from the database, and this one was loaded from disk. Also, instead of manually adding them, we can use this append random. You choose how many to add, and it will simply load them from your waveform database. It's not some waveforms that are randomly generated now. It's simply randomly picked from your tree view. So if I want to have a wavetable with 16 slots, I would tend to choose a higher number, for example, 20. I would remove these intermediate, and then I would look these through. Perhaps there are some I don't like. For example, remove that one. So by deleting some, I have now reduced my wavetable to have exactly 16 slots. And if you want to, you can start here, as explained before, press and hold shift and then arrow up and down to move the waveforms, or move the slots around as you prefer. Or if you want to, you can also add this shuffle function. It will simply shuffle the location of the slots, so you get a different result here. If you have seen this entire video, there was a section of all the changes made to the expression waveforms. And as you might recall, there was a new field in the expression called slot index. And there is actually a good reason for it to be named like that. So let's choose another database here. And go to wavetable. I have this slot generation. Here we see a wavetable that's invalid, and it's ensured that it will not be exported, as it's a wavetable I simply use as a template. In this wavetable, there is a single waveform, and this waveform is based on this new feature using these slot conditions. So as you can see, when I increase the slot index, it will generate different waveforms down here, and you can see with a slot index of 6, this is how the expression looks. And with a slot index of 1, it's a lot shorter. And if we dial in a slot index of 16, we'll have an even longer expression. And this feature you can use to generate slots. And it's only possible if the waveform is an advanced waveform and it's using the expression waveform. As it say here, from expression waveform, advanced only. It asked me how many I want to generate. And actually it will generate one less because we already have this one. So when I choose a value of 16, it will actually add 15. And as I explained before, the slowest waveforms in this program is indeed the expression waveforms. So it takes a little time to generate all of these. And also it's the reason that only the first remains being an expression. These have been resampled into a hand-drawn waveform. If you choose to edit them, it's simply a hand-drawn waveform. Whereas the first and original remain an expression. In case you want to change something to the expression, you can still do it. You can simply press delete to delete all these. This one you are not allowed to delete because, as the text says up here, you must have 2 slots. So normally what I do is hit Control Insert, Okay, I hit something wrong there, but normally I hit the control insert and then it will insert an intermediate and then I can delete that. So that's how you can generate multiple slots from a single expression. And what it will do is simply, it will set slot index to 1 for the first, set slot index to 2 for the second, to 3 for the third, and so on. So you can generate multiple slots. Let's say we want to make pulse with modulation. So we do a new one and insert a square, and we can dial in a pulse width and lower it to 3%. And this one we simply clone and change it to 50%. And move it down, and then we adjust the slot count to 16. So what you might expect is that we know this one is 3%. We have 3% here and 97% down here. And this last one, we have 50% here and 50% here. So as we transist between these, you might expect that this part up here simply become wider and this part down here become narrow. However, if you start to transist between these, you will see a completely different result. And you might think the program is wrong, but it does exactly what it's asked to do. When you have an amplitude transition type, it will simply look at each sample point between this waveform and this waveform. The program does not know that it's a square and it's using pulse width modification. It simply see a lot of samples extracted from the first waveform and a lot of samples extracted from the last waveform. This section of the of all waveforms is have the value -1. So this part will always be here down at -1. And this part up here at the first 3% of the phase of the waveform remains having the value +1. So this part will also never change. However, this part down here, the values will gradually change from -1 up to +1, and that's what we see here. However, there's another way we can accomplish what we want to. So let's delete these. What we can do is we can convert this top one to a partial. Double click it. A partial exists of 2 advanced waveforms. And what we can ask the program is to transist from the first into the second. So if I copy the second into this one and change it here to 50%. So as you can see, it's exactly the same waveform, basic waveform we have chosen. It's exactly the same phase converter we have chosen, and it's both left and right chosen as a phase converter 1. But the only difference is these variant values, that this one have the value of 3% and this one have the value of 50%. And the way it works is simply at these values have an index based on which item you choose. As it's 0 based, this first one have the value of 2. And as you can see, in this case, it's stepped by 1%. So this last one at 50% actually have the values of index of 49. So when I right click, I can generate slots, and this time it's not from expression, but it generates slots from a partial waveform, where we see it transists from advanced 1 to advanced 2. And again, the number you choose is not the number that will be generated. We choose here, it defaults to a value of 16, but you can choose more. But actually, it will only generate 15s, as this is one of them. And we can now remove the last one. And now, as you step through them, you see we have exactly the effects we wanted to have with a pulse width modification. If I double-click one of these advanced, you can see it simply have a specific value dialed in here in the phase converter. So let's add an intermediate and delete all these. Now let's change this. What we can also do is we can, for example, say we both say we keep them being a square, but we can say this first one is a square with 3 harmonic, and this last one is a square with 64 harmonics. So as we generate the slots again, we can see here now that we begin with few harmonics, and more is added as we transist through them. And we can do that with all of these. For example, we could do let's do a sample and hold, and we can dial in a large value, for example 12%, and then do a sample and hold again and dial in a very low value. And again, we generate the slot 16. So now we'll have more sample and hold effect on the first one, and it will gradually be less and less. Else can we do? We can take this one, clone the last one. Then we can remove the sample and hold. And we can change it into a symbol. And then hit the Control Insert a few times. So now we have these that were generated. Then we have some intermediate that shift into this last one that we manually made. So that's how you can quickly generate a lot of slots from either an expression or, as in here, a partial. One thing you should be aware is this only works as long as you use the same converters. For example, let's do shift and hold for the first one. And we do a sample and hold for the first one. And then we do a pulse width modification for the last one and change it to 3%. And let's do the one with 64. Now we have 64 up here. So there'll be no change in the actual waveform. But this first one is set to sample and hold with 5%, and this last one is set as a pulse width modification. So it's two different phase converters we're using. So now the program cannot simply transist from one into another. So instead, what it will do is it will simply, for the first 50% of the generated, it will keep the first selected phase converter. And for the last, it will use the last phase converter. So again, for this generation of slots to work as you might expect, you have to use the same phase converters. Phase converter 1 of both need to be the same. Phase converter 2 needs to be the same. Otherwise, you'll have this, as we see here, that the first 50% will use this one and the last 50% will use this one. So that's how you create your wavetables. Either you manually insert the waveforms you want to use, or you load them from the database, or you import them from WAV files. And you can choose to add as many intermediate as you want to. And once you have created your wavetable and it's not displayed up here in red or with a red asterisk here, it's valid and you can save it. Simply clicking OK and name it here. I'm asked to name it, but I choose cancel to not save this one. To export a wavetable, it's simply as easy as exporting waveforms from the tree view. It works the same way. If you right-click a single wavetable and choose export, it will only be this single file that's being exported, and it shows the preset you have set up in settings. You can either choose a preset and all the fields are locked, or you can choose this one, custom, and you are able to dial in the values. And these different fields are more or less identical to those you do when you export an audio file. Let's look here in settings. You don't have waveform count or sample drift when you export a wavetable. You see these fields are gone, but instead you have these minimum slot and maximum slot, and these increase to max slot and decrease to max slot, and you have a save as and this checkbox here. So let's return to this view. And information I forgot to give you all was over here. Whenever you select a wavetable, you will see this info extracted from it. Username, who made it, how many slots are there. In this case, there's a total of 10 slots. 4 of them are non-intermediate. 6 of them are intermediate. And here you can see the slots. You can see the first one is an advanced waveform. Then you have an intermediate, then an advanced, then 2 intermediate, an advanced, 3 intermediate, and advanced. And down here you see the illustration only showing the non-intermediate. However, you can double click and then include them here if you want to see them. So in this case, this one have 10 slots. So when I export, for example, if I export to a synthesizer that only accepts 5 slots, I can set it up here. I can say only include waveforms that have a minimum of 5 slots and a maximum of 5 slots. But also I could choose to say include all of those that have at least 2 slots, and I don't have to dial in a maximum, but I could say 5 slots. And I could check this box saying increase to max slots. It means if I have a wavetable with only 2 slots, when this checkbox added, it would automatic add 3 intermediate to increase its size to 5. I can also click this box saying decrease to max slot. It means this one we have here with 10 slots, it will decrease that to only include 5 slots. And the way it do it is it tries to remove enough intermediate waveforms. In this case, it have only 4 intermediate, non-intermediate. So it will remove most of the intermediate and only keep one of these in this range where there's most of them. However, if this waveform have had 6 non-intermediate, it would not be included because this feature can only either add or remove intermediate waveform. In this export preset, you can also choose how to export your wave slots. By default, if you not change the preset, it will export one file containing the full wavetable. But you could also choose to export all individual slots. When you export individual slots, they will use the file name of the slot, and then it will add an underscore and then slot and a 3-digit number. So the first slot will be 001, then 002, and so on. Or you can choose the third option, both. Hence, it will both export a full file containing all of the slots, and it will generate individual files for each of the slots. And finally, you can choose to normalize the slots. Normally, all slots are normalized together. So if you have one slot that's louder than every else slot, it will still, when exported to individual files, it will still be the one with the highest volume, or the highest amplitude that define how the other will be. If you click this one, normalize slots, each slot in each individual file will be normalized by itself. Here I right-clicked a single file, so only this single wavetable will be exported. Had I right-click up here and choose Export Wavetables, it will simply export every wavetable and will create a basic folder and insert these into the basic folder. It will create a random folder and insert these. So that's how the export feature of WaveSlots works. In previous versions, if you wanted to share your creations of waveforms with anyone, your only option was either give them your entire database, and using the open dialog here, they could choose your database or browse for it, and then open it, and they would have access to your database. However, if they wanted to import your waveforms into the database, you had to do it one by one. So, for example, you could choose to export a single file or multiple files, and then choose the raw format for the best quality. But the person you sent them to had to import them one by one. As you can see here, you have this import waveform, and it would take a long time. It was tedious work. In this version, I have made it possible to import a database into another database. So let's start by creating a new database. This one called empty. It does not exist. So I create it, and now I have an empty database. The only thing it contains is this waveform folder in the top, and this wavetables folder also in the top. So to import anything, I right-click and say import waveforms from database, and I can choose to import from my development database. And it asks if I want to override. In this case, it doesn't matter what I choose because I have nothing to override, so I just choose yes. And it will do the entire import. In this case, it was only 70 waveforms to be imported, so it was very, very quickly. And I'm told it created 10 folders. The database I imported contained 10 folders, of which 9 was imported. And the reason only 9 is imported because that database also have this waveforms folder that's not being imported, only the content of it. So in total, 70 waveforms processed, of which 70 was imported, and it took 600 milliseconds to do so. When I close this form, the tree will be repopulated with the imported things, and now I can simply scroll through what I imported. This time I chose to import directly into this waveform folder. And I recommend you don't do it. Instead, the best thing I think you should do is to add a new subfolder. Let's say that it was my friend Peter who sent me these files. So I can write Peter's waveforms. I have this folder. Now I right-click that and choose import. And again, I choose to import the development database. And it asks me if I want to overwrite. And again, it doesn't matter because even though these are the same named files and the same named folders, I now import it to another place that don't contain these already. So again, in about 600 milliseconds, it imported 70 waveforms. So if I want to delete those I have here, I simply press delete and enter. You cannot quickly delete a lot of waveforms. You have to delete, enter a few times. So now I have all these waveforms within this folder. I have a sound bank folder containing almost 26,000 waveforms. So let's create a new subfolder called sound bank. And I choose again, right click, import. And I choose to import from a sound bank. And I hit import. Again, it doesn't contain anything. So if I choose yes or no here, it's not important. And it will do its work. Importing such a large database as we're doing here takes some time. And the reason for that is for each and every waveform it imports, it needs to see if it is in the database already. And if it is in the database, it have to look, did you answer yes or no to override it? And when it saves it to the database, it either need to perform an insert operation or an update operation into the database. So it's actually very disk intensive to import a database. Let's look at the task manager. As you can see here, my C drive that I'm in use right now, it's fairly high usage to perform all these database operations, so to update the database. As you can see, it's not because it's very CPU hungry. It's simply the disk that's the bottleneck here. So I will pause the video for now and resume when it's finished importing. Now the import have finished. As you can see, 537 folders were imported and almost 26,000 waveforms. This entire operation took almost 5 minutes to import all these waveforms. Right now, you don't see any change in the tree view, but as soon as I close this form, it will repopulate the tree. And now we have this full sound bank imported into this folder. If you want to send a subset of your database to one of your friends, for example, this is my personal sound bank that I have loaded into this program. If I want to send only some of it to a friend, as I have imported into this empty, I can start removing some of the folders. For example, if I said I don't want to share this one, delete, enter. It have a lot of waveforms, so it takes a few seconds. And this one I don't want to share also, and perhaps this one I don't want to share. And now I could send this empty database to my friend and let him import it, and he will not have those waveforms I decided not to share. However, every time you delete something from the database, it's not physical deleted. The space is not released. It simply marked those areas of the database as unused, but the size of the database file is still very large. For example, if I right now have this import of my development database and I have this entire sound bank. So if I delete the sound bank folder, it takes more than just a few seconds because it's a lot of delete operations it have to perform in the database. Now it's deleted, but those places, as I said, only marked as unused. So if I were to send this file by mail or share it via Dropbox or something else, it would be a large file. So what you can do is you can compress the database, and that will release the area occupied by those areas marked as unused. You do that from the settings form. Here you choose which database. I choose the empty one, and then you hit compress. It's very quick to do, and we can see here that almost 29.5 megabyte was released from the database. So it really compressed the size of the database, and you simply click OK. When I close this form, I don't press OK here because that will change my default database. So next time I start the program, it will actually want to load this empty database. I don't want that, so I simply cancel this operation, cancel this change. So now when I go back to settings, it still remembers that I want to start the program by loading my development database. And the size of this database, empty database we're using now, have really been compressed to a very small size. When you import the database, as we did here from the waveform tree view, it will only import the waveforms in the database. If that database also contains wavetables, they have not been imported at this point. So we go to wavetables, create a new folder, call it Peter's wavetables. Then I right click and choose import, and it works exactly as it did before. So I choose what to import, hit the import, asked if I want to override. In this case, not important. And it's, in this case, I only had 22 wavetables, so it was extremely quick to import these. One thing worth mentioning is, I said it a few times, that expression-based waveforms are by far the slowest to use in this program. And it's very obvious in this development version of the program. I here list how long time it took internally to generate the data used to make this illustration. And in this case, it took 2 seconds, more than 2,000 milliseconds. And what the program does internally is if it takes more than a tenth of a second, equal to 100 milliseconds, to generate this thumbnail, it will cast this thumbnail. So as we choose another database, that was not another, for example, this one, and revert back to our empty, those things are no longer cast. So as you will see, the first time I click on this one, it will take some time before it generates the image. This time it took 1.8 seconds. And when I press arrow down, you see again, it will take a little time. And these are less than 100. However, when I press now, you see the image at once, because it's now cast. So when you cycle through your wave tables in the program, you might see the first time it make a stop because it takes longer time, and then next time you select it, it will be fast. This you don't see this value. I only have this displayed on screen in my development version. And also here at looking at the wavetables, the waveforms, it will also cast any waveform that takes where it takes longer than, I think I saw one here. Yeah, this one took more than 100 milliseconds to generate, so it was it's being cast also.